Here's the next example I would like to take a look at, and it is the same setup as the previous one, or is it? So I've got A is 8.4, B is 5.4, and side C is 16.4, all in centimeters. Some of you may notice a problem right away. Some of you may not notice that there's anything wrong immediately with this problem. It's okay if you don't see it yet. It's not like one of those pictures where one of those videos where it's like a field and it says post when you see it, and then like a few minutes into the video, like lions show up and they're like right there in front of you. It's not dangerous like that. Let's pretend that we do not see what's wrong with this problem right away. And let's just employ our normal strategy. We've got three sides. I do not have a set of opposite parts. So that means that we're going to have to use the law of cosines. My recommendation is to use the law of cosines to find the biggest angle first. For no other reason that it takes choosing off the table. It looks like our biggest angle is going to be gamma. So let's find gamma first. So gamma, like we got in the last problem, was cosine inverse of, open the numerator, a squared plus b squared minus c squared, close the numerator, divide, open the denominator, 2ab, close the denominator, close the cosine inverse. So we're going to start by practicing writing down what the law of cosines is for gamma. And then we can plug numbers into it. So I have cosine inverse of, open the numerator, a squared plus b squared minus c squared. Close the numerator, divide, open the denominator, 2 times a times b. Certainly something has gone wrong here. So when we try to put this calculation into our calculating machine, we get an error, a domain error. This is because we're trying to find the cosine of a number that's bigger than 1 or less than 1. That's what's going on here. So go to the error and says there's an error somewhere in here. Putting this parentheses at the end there, that's what caused things to mess up. So this did not give us an answer. This went straight to error, but specifically a domain error. It must be serious. It was written in all caps. So I don't know if that's a Texas thing that it just has to shout at you. Error domain. So here's why we're running into a problem. If we drop this cosine off and just look at the stuff inside, we're trying to find the cosine inverse of negative 1.86. No angle has a cosine of negative 1.86. Cosine is adjacent over hypotenuse. I know that this is not in a right triangle, but cosine is adjacent over hypotenuse. And in a right triangle, hypotenuse has to be biggest. So the cosine of any angle has to be between 1 and negative 1. Also, think about the graphs that we made of cosine. The middle was at 0, the top was at 1, the bottom was at negative 1. So what we're trying to do here is trying to do the cosine inverse of negative 1.866. No angle has a cosine greater than 1 or less than negative 1. The cosine of an angle has to be between negative 1 and 1. Think about the graph of cosine. Maximum 1, minimum negative 1. If we multiply this, then we can change the amplitude, but just cosine by itself, like we have here, has to be between negative 1 and 1. Or if we just think about our original definition of cosine, cosine of theta is adjacent over hypotenuse. Hypotenuse has to be biggest. And that means that adjacent divided by hypotenuse has to be less than 1. That's what's going on with this domain error. When we get a domain error, first thing we should do is to check to see that we typed the numbers in correctly. So first, I'm going to say, well, did I make a typo? I got the 8.4, 5.4, minus the 16.4, 2 times 8.4, 2 times 5.4. Yes, we type things in correctly. We're trying to find the cosine inverse of something less than negative 1. We are not going to find that angle. If we go back to our original information, we can't find a value for gamma that fits this description. That's because there is no triangle that fits this description. So the problem here is that no triangle can have these 3 sides. So in any triangle, the sum of 2 sides must be greater than the 3rd side. In any triangle, the sum of any 2 sides must be greater than the 3rd side. Otherwise, the ruling on the field is no triangle. In American competition, that's the signal that the referee will use. They'll just be like, oh, no triangle. It's different in other places. Like if you're doing trigonometry in a European league, then the referees do something different. They put their hands in a triangle and then they shake their head. So this is the ruling for no triangle. But in America, they're like, oh, no triangle. You've watched trigonometry competitions, right? On ESPN Pi. It's not a thing. Don't worry about it. I know some of you are like, oh no, that's not real, right? He hasn't confirmed that it's not real yet. Oh my God, is that real? It's not real. Which is weird because like in every other aspect of human endeavor, humans will turn it into some kind of competition. I know we have math competitions, but it's not like a big production where there's like a field and there's a bunch of mathematicians like out on the grass and stuff like that, because we don't go outside. But in every other area, you got to turn stuff into a competition. Everything has to be a competition. I don't know if this is an American thing. I think it's kind of a human thing. You know how like if you're in the airport, the police will come through with a dog, and the dog will be sniffing for like drugs and bombs and stuff like that. And if the dog walks up to your suitcase, it's like, oh, yeah, this one. That means you probably have drugs or bombs. And they're like, oh, we're going to need to open that suitcase. The dog is telling us that you got some stuff in there. I know the joke is, that's like, oh no, it's just a big bag of sausages. Ha ha ha. If the dog is properly trained and handled, it will not indicate on a bunch of sausages. You know how I know this? Because one of the things that humans do is have their dogs sniff for things. So one of the things that humans do to compete is have their dogs sniff for things as a sport. How do I know this? My dog is a sport sniffing dog. And I have to train him to sniff the right odors and not tell me that there's a bunch of sausages in this backpack. And that the odor that I'm actually looking for is over in that cabinet. Anyway, actually, I cannot confirm that there is not trigonometry competition, but I'm pretty sure they don't use referees with hand signals. But that's what would happen here. No triangle, or in a European league, no triangle. It's weird that they still use the hand signals because they have microphones. You know what I mean? Do they still like do the dance when there's a penalty? I haven't watched football in years, but do they still do the little dance when there's a penalty? Are they still like all pass interference? Or do they just say pass interference on number 38? They just tell us. Use the hand signals if like the microphone isn't working, but just tell us. You know what I mean? So when we look at our original set of information, I've got an 8.4 and a 5.4, and that third side is 16.4. 8.4 plus 5.4 is 13.8. So that third side at 16.4, too long, no triangle. You want to notice that right away, so you can immediately call no triangle and not have to do any calculation. So, but if you get a domain error and you go back and check, it's like, oh, I punched everything in to my calculator correctly, then go back and check. Wait a second, these two sides, if I add them up, it's smaller than this third side. So, no triangle. Any questions? All right, so remember your triangle inequality. In a triangle, the sum of any two sides must be greater than the third side. It might save you some typing on the calculator and some writing out of formulas. All right, that's going to do it for today. Next week, or next time, we will talk about other opening moves in the solving oblique triangle game. That's it for today. I'll see y'all on Thursday. Everybody have a good couple days, and thanks for playing.